Alright, welcome to our volume level 1 video, and in this video we're going to specifically look at three-dimensional shapes, or we can call them 3D solids, and we're going to focus on finding the area of the base. And the reason we want to do this is that we know that the volume is equal to the area of the base times the height. So in this video we're basically focusing on finding our capital B, the area of the base. Now, whenever we have a three-dimensional solid, we know that we always want to start by shading the base. And our base will always be the shape that we can only see two of them. And so when I look at this shape that we're given, this triangular prism, I know that there are only two triangles here. And so I want to go ahead and shade in my triangle. Okay, so I'll shade, 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 and shade, shade, shade. Now when it comes to this, I can go ahead and say, hey, my area of the base is equal to the area of a triangle, which would be 1/2 times the base times the height. Well, we can write this as 1/2 times, and when we look at this, we see that the base of that triangle is going to be 6 times the height, which would be 7, and we know that we now have 1/2 times, well, 6 times 7 would give us 42. And if we multiply by 1/2, that's essentially the same as dividing by 2. This will give us the area of the base is 21 centimeters squared. Alright? And once again, the area of the base really depends on the shape of the base. Alright, let me go ahead, and if you need to pause this, feel free to pause it and finish writing this out. But I'm going to go ahead and clear this off. And this will bring us to example 2. So for example 2, I want you to find, and I'm just going to shorthand this, I want you to find the capital B, which we know stands for the area of the base. Now in this specific example, I'm going to go ahead and draw a cylinder. And it should be rather apparent that the base of our cylinder will always be a circle. So let's go ahead and shade in that circle, let's shade in that base. And we know that really and truly the area of a circle always depends on the radius. So let's go ahead and say that this has a radius of 2 inches. Now we know that the capital B stands for the area of the base. In this case, our area is that of a circle. And we can look at our formula chart, find the heading that says area, look for circle, and we'll see the formula is pi r squared. Alright, so now let's go ahead and find out what that is. So we say the area of a circle is equal to pi times the radius, which will be 2 squared. And we want to ask ourselves, okay, what is 2 squared? Well, that would give us 4 pi. And in terms of pi, this is our area. Once again, I really do want you to get in the habit of learning how to write your values in terms of pi. And if you want, you can type this in the calculator. You'll get a decimal. 4 pi and that decimal, they are the same thing. If you need to, go ahead and pause this. And let me go ahead and start writing up our example 3. Alright. For example 3, I'm still going to shorthand. And I'm just going to write find the capital B. We know that that stands for the area of the base. And for this one, let me go ahead and draw this shape right here. And as I'm drawing this, I want you to think, can you name this shape? And so as I draw this, I think it's relatively apparent. We know that the base is going to be one of these hexagons, and we actually call this a hexagonal prism. Let me go ahead and write that out. This is a hexagonal prism. And let's go ahead and give this hexagonal prism some sides, and I want to do these in red so they really stand out. So right here, I will draw my apothem, and we'll say that that is 9 inches. And I want to say that, hey, each one of my sides is going to be 8 inches. All right. Now, oh, and I also want to say, hey, you know what? Let's take this length and let's say that that's 17 inches. But we know for this video that's going to be kind of irrelevant. Well, what's our step one? We always want to start by shading our base. So let's go ahead and shade this hexagon that we have here in the back, just because I don't want to cover up my numbers. So I start by shading the base. And so whenever we're talking about the base in this case, we're really saying, hey, what is the area of our regular polygon? And we know if we look at our formula chart, we can find that that is 1/2 A capital P, where A is our apothem, and we know that P is the perimeter of the base. So let's go ahead and write that out. So we'll say, hey, the area of our polygon is equal to, I've always told y'all I want y'all to change the 1/2 to a 0.5 times our apothem. We see the apothem is right here. That's going to be 9 times. And whenever we see the perimeter, a common mistake is that students will say, oh, the perimeter is 8. Well, that's not really true. We know our perimeter is this one side 8 times 1, 2, 3, 4, 5, 6 sides. And we know that 8 times 6 would go ahead and give us 48. Let me go ahead and draw that 9 just a little bit better. Now, if we multiply these three numbers together, well, we know that 0.5 times 48, that gives us 24. Now, I don't have my calculator handy, so 0.5 times 48 is 24 times 9, and let's see. So we're going to get 9 times 2, 18. And we know that this will be 216 inches squared. All right. Now, you'll notice that problem number 5 on this page does not have the apothem. So for that example, I would encourage you to go look through the series, finding the area of irregular polygons, level 1, 2, 3, and 4. But that's going to be too extensive for us to cover in this video. All right. Can't wait to see you on level 2, and good luck.